Section 5.4 Exponential Functions, Differentiation and Integration. The natural exponential function. We have learned that the function f of x equals ln of x is increasing on its entire domain. So it has an inverse function. For any real number x, ln of f inverse of x equals f of f inverse of x equals x by the definition of inverse function. Let's take a look at the exponential function. If x is rational, then ln of e to the x. Because of the power rule, we can factor out the power x, but ln of e equals 1. So it's the same as x times 1, that equals x. We see that ln of e to the x power equals x. Because a natural logarithmic function is 1 to 1, we can conclude that f inverse of x and e to the x agree for rational values of x. The next definition extends the meaning of e to the x to include all real numbers of x. That is same as saying it also includes the irrational number. The inverse of the natural logarithmic function f of x equals ln of x is called the natural exponential function, denoted by f inverse of x equals e to the x. The derivative of the natural exponential function d over dx acting on e to the x equals e to the x. And we can try to derive this based on what we have learned from the last section. F inverse derivative of x equals 1 over f prime of f inverse of x. Now in this case, f inverse of x is e to the x. F of x is ln of x. So f prime is 1 over the argument f inverse, which is e to the x. So e to the x is a derivative of itself. Based on this formula, let's take a look at exercise number 1. How do we apply this formula to take the derivative? F of x equals -7 times e to the 2x minus 1 power. So f prime of x, according to the constant multiple rule, we factor out the -7 times chain rule, e to the 2x minus 1 is its own derivative. Then multiply by the derivative of the inner function, 2x minus 1, we get the number 2. So to simplify, we get -14 e to the 2x minus 1 as a derivative. Now let's take a look at the next example. Again, it's a little bit complicated because we have a composite function. So we have to be careful. First, we try to rewrite f of x using the power form. We get 5 times e to the x plus 7 to the 1/2 power minus 4e. Next, we take the derivative. The constant remains. Power rule, power comes down. Power decreased by 1, evaluated at the inner function, times the derivative of the inner function. E to the x power is its own derivative, plus 7, derivative of a constant is 0. Subtract derivative of 4e, but 4 times e is a constant, so we get 0. To simplify, we get 5 over 2 times e to the x plus 7 to the negative 1/2 power times e to the x. And that is the derivative in example number 2. Let's take a look at example number 3. We have to apply the chain rule again. F of x is cosine of e to the x minus x. So f prime of x equal derivative of the outer function is negative sine evaluated at the inner function e to the x minus x times the derivative of the inner function. E to the x is its own derivative. Derivative of x is 1. So that is the derivative in example number 3. Example number 4, find the equation of the tangent line to the graph of f of x equal e to the x plus 2 square at the point 0, 9. So we are given one point. In order to find the tangent line, we will need the slope. In order to find the slope, we will need to take the derivative f prime of x equals, use the general power rule. Power comes down, power decrease by 1. So e to the x plus 2 is the inner function times the derivative of the inner function, which is e to the x power only. And in order to find the slope, we need to evaluate the derivative at the given point 0, 9. So x will equal 0. We get 2 times e to the 0 power is 1 plus 2 to the first power times e to the 0 power is 1. So we get 2 times 3 equals 6. The slope equals 6. Plug it into the point slope form. Y minus y1 equals m times x minus x1. So the tangent line is y equals 6x plus 9. Next, integration of the exponential function. Based on the derivative of e to the x, we can conclude that the integral of e to the x dx equals e to the x plus the constant c. Now let's use that formula to calculate the indefinite integral in example number 5. First, we apply the difference of integral rule. So we get integral of x squared dx minus integral of e to the 2x dx. And the first antiderivative is x cubed divided by 3 minus, for the second part, we have to apply the u sub, okay? So we will set u equals 2x because it's a composite function and 2x is in the exponent. Then du will equals twice dx. That means dx is 1/2 du. So we have e to the u power times 1/2 du. And we can factor out the 1/2, so we get x cubed divided by 3 minus 1/2 times antiderivative of e to the u is just itself, and u is 2x plus the constant c. So that is our answer for example number 5. Example number 6, we also need to apply the u sub because we're dealing with composite function. We will set u equals the exponent t squared. So du will equals 2t dt. That means t times dt is 1/2 du. So we get integral e to the t squared, so u power, times 1/2, we can write a constant outside, du. And the antiderivative of e to the u is just e to the u. So u is t squared plus c. So the antiderivative is 1/2 e to the t squared power plus c. Let's take a look at example number 7. We're dealing with a composite function, and u is usually in the denominator under the square root or inside the parenthesis. And in this case, it's under the third root. So the u equals e to the x plus 1. And then du will equals the derivative e to the x is e to the x itself. Derivative of 1 is 0. So du equals e to the x dx. Now we can substitute everything in the integral. E to the x dx will be replaced by du. E to the x plus 1 is u. And it's 1 over the third root. So it's, the power is negative 1/3. And the antiderivative of the negative 1/3, using the power rule, we get u to power increased by 1, so 2 over 3, divided by the new power plus c. And we replace the expression for u back and simplify. We get 3 over 2 times e to the x plus 1 to the 2 over 3 power plus the constant c. Example number 8. You may think about, should I use u sub? Well, if you replace 3x by u, it doesn't really simplify the expression. So we need to first dividing the numerator by the denominator. So we get integral e to the x divided by e to the 3x is e to the negative 2x power minus e to the negative x divided by e to the 3x is e to the negative 4x power. So once we divide everything out, it's a very simple integral. We get integral e to the negative 2x dx subtract integral e to the negative 4x dx. Now we apply the u sub for two different ways. Okay, the first one is u equals negative 2x, and in this case we will get e to the negative 2x times 1 over negative 2 in the front. For the second part, we also get e to the negative 4x, but in this case we gain a constant, negative 4, in the front. So to simplify, the final answer will be negative 1/2 e to the negative 2x plus 1/4 e to the negative 4x plus c.